Okay, so in your homework you will see designated find the area between curves from here to there. That means they won't be crossing. And then it's going to say find the areas between curves that cross, and it's going to say from. So it will also give you the limits of integration. So we're in situation number 2 basically, okay? So I'm just going to graph it really quick for you, just to show you because it's easy. And because you've already done all this stuff. So I'm going to start with the line again. So it's crossing at 5. I don't need an exact super graph, but I just need an idea of who's above and who's below. So, and then it goes 4 units up for every 1 unit to the right. So it's definitely a pretty steep line. So here's my g of x. Now, my f of x is a quadratic function that's stretched by a factor of 2 vertically and is moving up 5 units. So it's going to also start at 5. Now, I wish I could zoom in, or I would have graphed this a little bit closer. But as you see, they are crossing. Yes, where are they crossing? For sure at 5, right? But they're also crossing again. We're going to find that. We want the area between what and what? Between -3 and +1. So between -3 and +1. There you go. We're making these two boundaries. -3. Here they cross, and at 1, they cross again in between here. Okay. So I'm going to find that crossing point. How do I find the crossing point? I am going, plus the problem says they're supposed to be crossing, yes? So I'm going to set them equal to each other to find those intersection points. So when is 2x plus 5 equal to 4x plus 5? Now, that's a quadratic equation. So what we want to do is move all the terms to one side of the equal. When I minus the 5 from both sides, they're going to go away. So minusing 4x. And as you see, I can factor out a 2x. So the two crossing points, as we already know, were one at 0, right? They start in the same point on the x-axis, on the y-axis, I'm sorry. And then the other one is at 2. So past our limit. And yeah, again, it kind of looked to me like they're going to cross past the 1, right, value, right? So they're actually crossing at 2. So in between -3 and 1, they have switched once, right? Between -3 and +1, these graphs have switched once, right? Or they've crossed at 0. So it's clear from the graph who's above and who's below. But let's pretend that we didn't have the graphs and we wouldn't know. So we know between -3 and 1, they've crossed at 0, and we're going to have to split the graph. So pick me a value between -3 and 0. A good value to pick would be -1. Now, I don't know if I want to write it, but here, -1. I'm going to test -1. When I plug in -1 in here, what do I get? 2 plus 5 is 3. And then -4 plus 5 is 1. So between 3 and 1, 3 wins, right? So F is above G, as we could see clearly from the picture, right? The parabola is above the line, yes. Okay, now between 0 and 1, you can take a test point again. Obviously, they're switching if they're crossing, but sure enough, if you want to test it, you can pick a point, let's say 0.5. 4 times 0.5 is 2, plus 5 is 7. 0.5 squared is a quarter, times 2 is a half. 5.5 is less than 7. So the function g is winning between 0 and 1. Okay, but again, pictures are even faster maybe sometimes. So either one, right? Either you have a picture or you pick a test point. You don't need both. So between -3 and 0, the function f of x is 2x squared plus 5, minus the function g of x is 4x plus 5. And backwards from 0 to 1, you have 4x plus 5 minus 2x squared plus 5. So it's a little bit of computation, but nothing crazy. So between -3 and 0, combining this, I have a 2x squared minus 4x. And between 0 and 1, I have backwards a 4x minus a 2x squared. They're opposites, right, of each other. You don't need to actually combine all these terms, but fine, do. But, right, when we switch the order in a subtraction, you just simply get the opposite of what you had. So, there you go. Let's find the antiderivative. So it's going to be 4 separate parts. So it's going to be a what? 2x to the third over 3 minus 4x squared over 2 between -3 and 0. And then you have 4x squared over 2 minus 2x to the third over 3 to be evaluated between 0 and 1. Okay? So, start at 0 minus the -3. When you start at 0, those are both 0. 2, 0, 0 squared, and so on. Plug in a -3, that's the one. So I have a 2 times -3 cubed over 3 minus, by the way, that gives you a 2 times -3 squared. Plus, I'm going to find these parentheses, plug in a 1. So 2 times 1 squared minus 2 times 1 to the third over 3 minus really a bunch of zeros, yes? Okay, so put that in your calculator. And by the way, I had some numbers. That's going to be -27 divided by -18. -18 minus 18. See how there's a minus in front? And that's a -18 minus another 18. So that really ensured with this extra minus in the front that you get a positive there. Plus, this one's a 2 minus 2 times 1 with minus 2/3. Okay, and then a bunch of zeros. So that's a -36. I'm sorry, positive 36 with the extra minus up front, right? And then plus 1 1/3. So that's going to be a total of 37 1/3 square units. And there you have it. Okay, so again, put it in your calculator. I did want to go slowly, step by step, to show you how each of these parts become positive, and you're getting a positive area, right? If it turns out negative, then something went wrong. All right, let's try another one. And this time, I'm just going to give you the third situation, and I'm just going to ask you to find the area between, and I'm not giving you limits of integration, f of x is equal to x squared minus 4, and g of x is equal to 8 minus 2x squared. So that tells you that they're crossing, yes? And you have to find the area between the crossing points. Now again, of course I do want to bring back old memories, and I want to graph both of these. So by the way, you have a review of all your functions that you've been graphing in college algebra, just to give you one more time an idea. I'm not going through all the transformations, but I'm just reviewing. This is what a linear function looks like. That's what a quadratic functions look like, and things like that. So that's an upward looking quadratic function. This one, see how the negative is in front of x squared? That makes the parabola go down, and that's going to cross at 8. So sure enough, they're not going to come back, right? Parabolas are turned one time, yes? That's another parabola that's turned one time. So we're just going to find 2 crossing points, and that's going to be it, right? And we want to find the area trapped between them. So how do I find the crossing points? I'm setting the 2 functions equal to each other. So anytime you solve quadratic equation, you got to move all the terms to one side of the equal. So we're going to add the 2x squared for a total of 3x squared, minus the 8, so that's a -12. So that's a 3, x squared minus 4, right? Which we can factor some more, as we've done many times, into an x plus 2 and an x minus 2. So the 2 crossing points are at 2 and add -2. And you can easily see, and if not, you're welcome to put in a test point. Plug in 0, right? 0 is in between. So when you plug in a 0 in both these functions, that gives you a -4. That gives you a +8. Obviously, 8 is more than 4. So as you see, the parabola, the downward looking parabola, is above on this interval. So what do we start with? We're starting with the g function, that's higher, minus the function f of x, which is the lower function. All right. So I have to find the integral from -2 to 2. It's going to be an 8 minus -4, which is a 12. -2x cubed minus 1 more cubed is a -3x cubed, not cubed, squared. And by the way, kind of see right here, the same two terms, but again, make sure, depending who you're subtracting from what, it might be in a different order, but those are the same terms. Okay, so let's find the antiderivatives. The antiderivative of 12 is 12x minus 3x to the third over 3, evaluated between -2 and 2. That's it. So I'm going to reduce this. So I have a what? Plug in a 2 first, so 12 times 2 minus 2 to the third minus 12 times -2 minus -2 to the third. And again, be careful. Again, same thing, right? Always from lower to higher value, right? These limits of integration, we just don't grab them in any order. It always has to go from low to high. So you start with a higher value, so that's 24 minus 8, which is 16, minus, that's a -24, that's a -8, minus 8 is a +8, so as you see, you have a 16 minus a -16, which turns into a positive, so that's 32 square units. So, yeah. That's why we always take less from more, so we end up with a positive value in the end. Okay. All right. So let's try one more of these, where we have you find limits of integration. So I'm going to ask you to find the area between these two functions. F of x is equal to 4x and g of x is equal to x cubed. So same thing, I'm not giving you the limits of integration, which means what? You're going to find them yourselves, right? So you set them equal to each other. What I'm going to do is minus the 4x. So sure enough, almost the same factorization from before, except for now, the difference is that the factor up front is not a constant, but it's an x value. So x could become 0. The problem before, what did I factor out? I factored out a 3. Well, 3 ain't going to be 0. 3 is 3. Plus, in a quadratic equation, you know how many answers are you supposed to get? 2 answers, yes? This is not a quadratic equation. This is a cubic equation, so you better get 3 answers, yes? X could be 0, 2, and -2. So apparently, there are 3 intersection points. So they're not just going to cross 2 times. They're going to cross 3 times. Again, you could just pick a test point between, you put them in order, right? -2, there comes 0, and then comes 2. Pick a test point between -2 and 0. Pick a test point between 0 and 1. Plug it into both these functions, see which one's above. But of course, I'm just going to draw it for you. 4x is a line that goes through the origin, right? The y-intercept is 0, okay? X cubed looks like that, the cubic function, right? It dips in and it dips back out. So as we saw, we have 3 intersection points. Where are my 3 intersection points? One at -2, the other one at 0, and the other one when x is 2. So according to this picture, I have 2 parts to my integral. I want to find the area between -2 and 0, and which one's above in this case. The cubic function's above, so that's the g of x. And then from what? From 0 to 2, which one's above the line? So f of x minus g of x. Okay. All right, so as you see, you have to swap them. Again, plug in a test point. Yes, you can easily find which one's higher and which one's lower. And you plug in the 1, 4 versus 1. 4 is higher, right? So on the positive side, f is more than g. You plug in a -1, you get a -4 and a -1. -1 is higher, right? So g of x comes first. Okay. All right, so either way, this is going to be the integral from -2 to 0. Now comes all the mechanics part. G of x is x cubed minus 4x. Then from 0 to 2, it's backwards. So let's find the antiderivative. That's an x to the 4th over 4 minus 4x squared over 2 between -2 and 0. And this one's backwards. Now, I know I'm writing way too much. In other words, you could have already started plugging in values and not have to copy and write g of x. I just want to kind of go a little bit slower, make sure you get it. So let's plug in the 0 first. Those are a bunch of zeros again. Then comes the -2. And there comes the 2. And there comes the zeros, right? So that goes away. So plug this in, by the way. This is going to be a 16 over 4, which is 4 minus, that's 4, 8. So that's -4. Plus, that's going to be a +4, just the same, and then the zeros, so that's going to be a 4 plus 4, which is 8 square units. And sure enough, you probably already noticed that we got the same value. That's a 4. This integral was equal to a 4, and this integral is 4 units, yes? And that's because these functions are very much symmetrical. The areas are going to be the same, right? They're both what we call odd functions. In other words, symmetrical about the origin. So really would have been enough to find one of these areas and just double it up, right? So as you saw, you got the same exact answer from both sides, a +4 and a +4. All right. Let's try one more. I have a couple more problems for you. Okay, here it is. Find the area. I think that we need a little bit more practice on functions that do cross. And here is this. From x equals to 2 to x equals to 5. So we are giving you the limits of integration, but does that mean that this is it, or are these functions possibly crossing in between? Okay, so sure enough, as I said in the homework and on a test, I will tell you, you need to find the crossing points. But just to be safe, you always should. I'm in no mood to graph these functions this time. Why? They're not really easy functions to graph. I don't want to sit and find the vertex, intercepts, and so on and so on. It's not just some shifting. So this is going to be a lot. So just to be safe, let's say I'm not even telling you anything and you have to test it. What if they're crossing, right? So let's see. I'm going to move all terms to one side of the equal. So that's a 2x squared minus 11x and plus 12. And then I'm going to try and factor this for you. They should be factorable. Numbers that multiply to 12 should be 3 and 4. Negative, negative. So that's a negative 3, and that's a negative 8, which adds up to the negative 11 in the middle. So that means we factored correctly. Okay, so what are the two possible, or the two crossing points? They're going to cross at x equals to 4. And they're going to cross at x equals 3/2, right? Or 1.5. Okay. So, are there crossing points between 2 and 5? Sure enough. They're going to be switching at 4. And by the way, they're both upward-looking parabolas. They cross at whatever, 1.5 and 4, but that's what kind of what they would look like. Okay, so I'm going to have one integral from what to what? From 2 to 4. And another one from 4 to 5. Now I have the task, without having graphed them, to decide which one's above and which one's below. So I'm just going to pick a test.